linear systems, plainly, is just finding, the goal of a linear system is we have essentially two things happening. And you want to find the intersection of the two things, okay? And understand what the intersection means, okay? So we're going to have, we've been working with different situations, different descriptions, different equations. But what we want is to figure out, we're going to have two equations and figure out where they cross and kind of interpret what it means. So we have a little story here, okay? So the first one says, Logan and Jacob are participating in a readathon to raise money for the Humane Society, okay? So Logan's grandmother pledges $35 plus $5 per book. Okay, so that's one set of information. And then Jacob's grandma says she's going to do A equals 12B, where A is the amount pledged and B is the number of books read. Okay, so we get $12 per book. Now let's go back to Logan here. Okay, let's try to write a formula for him. So Logan's grandma pledges $35 per $5 book read. Okay, so that would mean our amount is going to equal 35 plus $5 per book. So there's our equation for him. Okay. Then our equation over here for Jacob is going to be amount equals 12B. So $12 per book. So the first thing I ask is make a table of values that shows how much money each boy collects reading up to 10 books. So I'm going to start over here at Jacob, and we're going to go every 2 books. 4, 6, 8, 10. And the way we do this is we're just going to plug those numbers in. So the first one we're going to do is where we're going to plug in 0. So 12 times 0 equals 0. So when he reads no books, he gets no money. Now if he reads 2 books, it's equal to 12 times 2, which is going to equal $24. So 24. Then if he reads 4 books, it's going to be 12 times 4, which is going to be $48. 48. And we can keep going here. Times 6, as my computer does something funky. That's 72. Now if you look, we're going up by 24 each time. So you can make a guess of what this next one's going to be. Plus 24 is going to be 96, as my pen is wandering. There we go. And we're back. 96. And then lastly, this one's going to be 120. Good. So that's Jacob. We got all his information down. Now for Logan. So we're going to do the same thing. Same intervals. And 10. Now, we're going to do the same thing, but this time for B. This is our variable B here, and this would be our variable A. We're going to plug in 0. So A equals 35 plus 5 times 0, which equals 35 plus 0, which is going to equal $35. So this one's going to be 35. Now if he reads 2 books, it's going to equal 35 plus 5 times 2 now, which equals 35 plus 10, which equals $45. 45, and We'll do one more. Times 4 equals 35 plus 5 times 4, which equals 35 plus 20, which equals 55. And you can see every time we go, every time we go up, or every time we go up 2, we're going up $10. So we can make 65, 75, and 85. Okay, and let's graph both sets. So we're done this step. Now let's graph. So we have to remember our independent variable is books. Our dependent variable is amount, because the amount depends on how many books. So I'm going to have books down here, and then amount over here. Now books here, we can go up by, if we look at we can go up by 2. We have to make sure our intervals are right. So I'm going to skip 1, go 2, skip again, go 4, and then 6, and then 8, and then 10, then 10. Oh, why I wrote 9 there. And this here is 10. Now going up here, we can take a look at our highest number. We say, okay, 120 is our highest. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So if we make every one of these worth 10, right? But I'm only going to mark every second one, because it would be really messy if I did every one. 60, 80, 100, 120. So now, the key thing here is my spacing is always the same. My scale is always the same. It's always 10. I didn't put the 20 down here, then skip 2. So let's do some marking here. So let's mark our first point. So I'm going to do Logan first. At 0 books, he's at $35. There's going to be about here. Oh, there's my dot. At 4 books, he's at $55. Oh, sorry. At 2 books, he's at $45. So 2 books, 45, dot. At 4 books, he's at 55, dot. 6 books, he's at 65. Doing my best to dot it here. 75. And last one is 85. So let's put in a line. So I'm going to insert a line. I'm going to start here and try to do my best line possible that gets them all. I'm going to make that skinny. Good. So that's point 1. Now person 2, I'm going to do Jacobs. So let's do here 0, 0 for this one. 2 and 24. It's going to be about there-ish. 4 and 48. Could be about there. 6 and 72. Maybe about there. 8 and 96. 8, 96. Okay, there. And 10 and 120. Maybe about there. Okay. So I made my dots. Let's go back, insert my line. Try to do my best line possible. There we go. So the question is, so we've now graphed them. Check. Right? So let's check that off with a big fat marker apparently. Change my pen. So now, where do they intersect? Okay. So where do they intersect? If we take a look, they intersect across right here. Okay. I'll circle it with black right now. Draw your attention to it. More specifically at 5 and 60. Right? So I draw a line here, up to 5 over the 60. So they intersect at 5, comma 60. Okay, so what does that mean? Well, if we interpret in books, if we think about books, so we go at 5 books, they're the same. Okay, but what are they the same? They both make $60. Perfect. So at 5 books, they both make the same amount of money. After 5 books, Logan is going to make less. After 5 books, Jacob makes more. But before 5 books, Logan makes more, and before 5 books, Jacob makes less. Okay? So that's our point of intersection, and we did it by graphing using a table of values, right? And we couldn't find it, we couldn't see it here because we didn't do 5. If we would have saw 5, we would have saw it matching right here. But we just happened not to do 5. So let's do this one now. So in Mrs. Johnson's Ventures class, Rob is going to sell Sundays. His fixed costs are $12 for supplies, and it costs him $1.25 per Sunday. So here's our first set of information. Okay. Our second set says he will sell the Sundays for $2.75 each. So we need to make a equation for revenue, which is the green, an equation for cost. So if you want to pause the video here, you can go and make those equations and double check if you see if you have it right. So, since you're back, let's take a look at the cost. So what's the cost entail? He has a fixed cost of 12, and it'll cost him $1.25 per Sunday. So the costs are going to be 12 plus $1.25. Okay? And his revenue is going to be just $2.75 each. $2.75 S. Oh, I forgot the S here. S. Okay. So cost $12 for supplies, initial cost, plus $1.25 per Sunday. So that'd be like ice cream and sprinkles and bananas, whatever. He's going to make $2.75 per ice cream. So graph the equation on the same grid. Okay. So what should we go by this grid up here? So let's go by $5 here. So that's going to be 10, 20, 30, 40. Okay? 5, 10, 15, 20. Let's go here by 2s. As in 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, we can't really graph this from the equation because the numbers are kind of weird. What we can do is we make a table of values and just make a couple points off it. We don't need that many points, right? So let's do here, we're going to make, let me think here, the number of Sundays and the cost, okay? Let's go 0, 2, 4, 6, 8, 10. Now realistically, we could just do these two and get a straight line, okay? So let's do that right now. So my cost equals 12 plus 1.25 S. So this is our number of Sundays. So 12 plus 1.25 times 0. Anything times 0 is going to disappear. So that's just going to equal 12. Now if we sell 2 Sundays, our cost is going to be 1.25 times 2, which is going to be 12 plus 250, which is going to equal 14.50. Good. 14.5. So we can just graph that, and that'll give us 2 points to graph. So our first point is 0, 12. So 0, 12 is going to be about there. Our second point is 2, 14.5. So 2, 14.5 is going to be about as close as you can get, maybe there. Let's do one more, just to make sure. Let's do 4. C equals 12 plus 1.25 times 4. So equals 12 plus, that is $255, which equals 17. So let's do that up there. Let's go to 4 and go to 17. Perfect. And then let's insert a line. Insert our line. Your graph is going to be much nicer than mine. Maybe not as colorful, except for maybe Regan. There we go. So now, let's go back and do the revenue part. So in this case, revenue, where should I put the table of values here? Let's go right here. So this is Sundays and this is revenue, right? And both of these are money. So you do money for both of these. So 0 to 4. So 2.75, let's do the first one at 0. That's going to equal 0. And then the revenue for the second one is 2.75 times 2. Revenue is going to be $5.50. 5.50. And revenue equals 2.75 times 4. What's that? $11. Correct? Yeah. Oh. Come on, old computer. So let's plot our point. 0, 0, right in the corner. 2, 550, so just above there. And 411, just above there. Now let's insert our line. There we go. So now we have a point of intersection where the two lines cross. Now let's say it's about 8, right? My lines aren't perfect. I could fudge it a little bit and just go point. Perfect. 8. Right? But we're right close to 8. And I'm never going to give you something that's in the middle. Right? So graph the equations on the same grid. Boom. We find our point of intersection, which is purple or pink will work a lot better. Point of intersection is right there. Then it says how many Sundays will he need to break even? What break even is when his revenue is above his expense. So we know so he will break even. Oh, okay. At 8 Sundays. One of the worst letters ever. Perfect. So before 8 Sundays, he's losing money, but then after 8 Sundays, he starts to make money. Okay. So that is your little, hopefully quick, and you understand linear systems. Okay. Have a great day.